Welcome to Module 6 on Overview of ABC Projects in Connecticut. We're pleased to again welcome our speaker, Tim Fields, Connecticut State Bridge Engineer. Tim?
Okay, thank you, Mary Lou. So we're concluding the module today, overview of ABC projects in Connecticut. As we noted earlier, our ABC experience started in the late 1980s with limited projects, but there were two very significant projects with precast deck panels as the ABC methodology. Mike spoke in great detail on those two projects in our first module. We had a little bit of a lag there, but we had really an acceleration in 2011, I think, with FHWA getting fully on board and endorsing and pushing ABC methodology through their everyday counts initiatives. And in 2011, we also put out our first engineering directive at that time, encouraging our bridge designers to look at ABC seriously as an alternative to conventional construction to help expedite projects, reduce our user impacts, and increase workplace safety by reducing the overall presence of durations of contractor and state personnel and inspector personnel on the ground in construction zones. So what have we done over these years here for ABC project types, the quantities and types? This slide actually provides the data that we've been able to put together here. We may be off a little bit, but this is, I think, fairly close to what we put out, a total of 138 projects to our best count. And this is the project types. Prefabricated bridge elements / modular deck beams, 105 projects. Of the 138, that's 76% of our total ABC projects. Within this group, we are also including concrete rigid frames, that may be over streams, as well as arches, and then modular deck beams. Precast deck panels, 5 of those of the 138, and we'll talk about reasons why there aren't more of those. 13 projects with precast substructure components with prefabricated bridge elements and modular deck beams. So these are 13 projects where your whole substructure, abutments, and wing walls are all precast, along with the spanning elements, whether it's a rigid frame or a modular deck beam. We're including 8 GRS IBS projects in here. And let me qualify the 138. These are projects that are either constructed or designed. We happen to have a lot of GRS IBS projects right now in design, more so than what we've constructed to date. 2 lateral slides. One of those is being advertised right now, and the other one I'm going to speak to later in this particular module. 5 SPMTs, where coal superstructures are moved into place either on new substructure or existing substructure. So reasons for ABC use. In a master spreadsheet we compile to keep track of these projects, the number one reason for use of ABC is time savings in construction, and this is directly associated with cost savings with an ABC approach. As we saw before, there can be significant cost savings in ABC projects. As a result of reduction in overhead on the part of the state and its consultant inspectors. Other reasons are avoiding complicated and staged construction conditions that can be avoided oftentimes with full shutdowns and the safety improvements that go with that for work zone safety. And then lastly, the overall reduction in traffic impacts to the traveling public. I can't think of one ABC job that we put out where we had complaints back from the public over what might be fairly significant but short-term traffic impacts. The overwhelming response to our projects is appreciation that we're able to get in and get out so quickly. So those short-term disruptions with long detours are for them a small price to pay for a much lesser presence on the ground than some of the conventional bridge projects that we've put out in the past. So why do we have 75% modular deck beams or rigid frames as our ABC projects? I'm listing mine here in these bullets that you can see on the screen. Typically, it's due to a more cost-effective approach in replacing the entire superstructure versus redecking a bridge. Often the bridges we're looking at right now here in these projects are 50 to 60 years of age. They're steel deck girder spans often with serious corrosion and poor paint. And they're in the 40 to 80 foot span range, which makes placement of modular deck beams very cost effective. And going back to the service condition of these present superstructures, it's often more cost effective to replace the entire superstructure than it is to undertake the steel repairs that are often needed, along with painting the bridge at the completion of, say, a deck, deck replacement. So that, that's basically why we have evolved in that direction here to really find that the replacement of the entire superstructure here is more cost effective. And we do life cycle cost analysis that also bears that out. So right now I'm going to just go over 3 examples. Mike has presented 2 examples here. Actually, Mike presented our deck replacement using precast deck panels in our Waterbury and Seymour projects. And we have seen also another deck replacement in our Waterford crossing of 395 over Route 85 and GRS IBS bridge substructure construction in conjunction with a standard superstructure installation. So this one here is a PB, a modular deck beam example. This is 35 State Project 35194, Old Kings Highway North over I-95 in Darien. The original bridge was constructed in 1952, and the bridge project here was to be a rehabilitation. Through a study of the bridge condition and alternatives, here it was determined that the deck needed to be replaced in any case, but the bridge had undergone a number of bridge hits because of substandard vertical clearance, also had a very poor paint system. So it was decided here that bridge replacement would be the most advantageous solution here. And for that, PBEs were looked at here through using the earlier pilot ABC decision matrix found that PBEs was the optimal ABC approach to use in replacing the superstructure here of this bridge. And it turned out this bridge could be replaced in one construction season, the superstructure that is. So this is a plan view looking at the proposed bridge over I-95 at this location of about 170,000 ADT of traffic. Bridge south elevation looking here. You'll see the new superstructure the substructure was stepped up to be able to raise the superstructure with a shallower superstructure to achieve design vertical clearance, Ashto compliant vertical clearance. Bridge cross section showing modular deck beam. You see the closure pores between the various segments here, the two girder segments. And a plan elevation showing the closure pores and the link slab construction over the center pier. Cross section of the link slab construction. So this obviously was cast after the spans were all fully dropped in place. And the erection plan showing the placement of cranes during the erection of the superstructures. These PBUs or modular deck beams. I'll say that these were all done during Sunday night closure from about 10 o'clock on a Sunday night through 6 a.m. Monday morning. I believe there were 4 of these closures of Old Kings Highway allowed to make this happen. Traffic was halted momentarily over I-95 when these modular deck beams were dropped in place. So one side of the bridge was done at a time, as can be seen from the erection staging. And this is a elevation shot photo of the completed bridge. Bridge 37, Route 1 over I-95 in Stamford. This was originally to have been a deck replacement project. This had been on our books for a long time. Unfortunately, it would have required 5 stages of construction to accomplish a deck replacement over a multi-year period due to the very high traffic demands on this 4-lane span across I-95 in Stamford. Actually also include a turning lane as well. And that was the duration here with the traffic impacts was just presented unacceptable proposal to the town. And this project was dormant a little for several years while the department worked on what to do, how to go about replacing this bridge deck. But you know, with the success of SPMT methodology here that we saw elsewhere here, and what we one of our own success stories took place in Southington on Marion Avenue over I-84, inspired our designers to look at using SPMTs to replace the entire superstructures, not just the deck, even though the steel was actually in pretty good shape in this project. But SPMTs opened that opportunity to be able to deal with this project in a much more expeditious way here. In fact, as you'll see here, we have a construction duration that was only 427 days. Again, we're dealing with a crossing here of 170,000 ADTs on I-95 and 17,000 ADT on Route 1 here, Main Street over I-95. So the work was accomplished through 2 weekend closures of Route 1 with I-95 basically bypassed down Diamond exit and entrance ramps. Most of the traffic we encouraged to detour this area or warned drivers well in advance before they even got into the state of Connecticut that there would be impacts, major impacts during these weekends. For more information on this particular bridge project, see the 2020 FIU webinar, an ABC webinar that we did a short while ago here. So this is an elevation view of the existing bridge before construction. And this is a shot looking south on Route 1 from the north abutment of the crossing, or east abutment, if you will. And this is a plan view of the proposed new bridge spans, bridge elevation of the proposed new superstructure. two-span bridge with 125 highly skew bridge, 125 foot span 2 with span 1 ranging between 108 and 117 feet, and a cross section of the new bridge. Utilities obviously were taken out of service on this during the bridge moves. That's actually an element that comes into play in our decision matrix, ABC decision matrix, because that could actually be a showstopper in an ABC project if there's a major delay in shifting during construction, if utilities need to be accommodated during construction. So this is a screenshot from the contract plans showing the diversion of I-95 onto two ramps here, the existing off ramp here, and this was actually a temporary on ramp that was built. And same thing on the other side here, traffic was handled 2 lanes each direction using the existing ramps, widened a little bit to accommodate traffic. On I-95, during the time period that the span was actually moved into place, Route 1 was shut down during that period. So this occurred during 2 weekend moves. This is a shot showing the construction of the spans here before they were picked up by the SPMTs. This is span 1 that would be going into a location to the left of what you can't see on the screen, and this is span 2 that would be installed right here, running down the highway ramp and onto the interstate highway that was prepared to receive the SPMT machines. Here you can see the span 2 being rolled into place. One of the lessons learned here is make sure steel plates are used wherever possible during final positioning of the bridge, so turning wheels do not settle into a pervious backfill. A little difficulty with the final alignment of the bridge because of that reason. The skew condition of the bridge here actually did pose some challenges during its installation, but things went on schedule, and contractor did meet his scheduled deadlines, avoiding any disincentives and collecting incentives. An aerial shot showing the completed superstructure in place. The temporary ramp that was installed here is now being removed, and we're back to traffic on Route 1 and 95. And an elevation view of the bridge completed in place. Another one, completed bridge looking northbound. And a photo from the deck looking southbound here on Route 1. The next project I want to discuss is a lateral slide project. Excuse me, that we did. This project was bid in 2015. It's a very short span, 1958 original construction for Bridge 352A and B, I-95 over Oil Mill Road in Waterford. This bridge originally required a deck replacement as a minimum. It was very narrow deck with substandard left and right shoulders. Several options were looked at here for this bridge using precast deck panels, but because of traffic conditions, all options, the precast deck panel option or even casting in place would require temporary widening for the duration it would have taken to accomplish the deck replacement. So we looked at basically a lateral slide method to try to reduce that duration where we might have to, where we would in this case be taking Route 95 down to one lane. You'll see in this location, the ADT on I-95 is 28,450. On the project we last looked at, it was 170,000. So you can see the I-95 ADTs really vary drastically across our state. Oil Mill Road, only 400 ADT. So, and the opportunity to close this road during a lateral slide, during the actual lateral slide with this low ADT was not really a challenge. So anyway, with a lateral slide proposal as a construction methodology here, we're able to design this bridge project and select 441 calendar days for construction. This project would have easily been a year longer, if not more, with conventional construction. And our low bid on this project was $4.9 million in 2015. So this is an existing photo of the existing bridge looking northbound prior to the job, and an elevation of the bridge looking northbound on Oil Mill Road. So both spans would be replaced in this project. So a plan, an elevation view of the northbound bridge. And similar for the southbound bridge. So the selected superstructure alternative was next beams type F here with a full deck that would be cast on top of next beams in their pre-construction, in their fabrication location. This shows where the erection of the superstructures were taking place. Each bridge would have two halves that would be slid in over a week period. Actually, each slide took place over 34 hours. This is, we're looking at stage one construction here, where the left lane is replaced first. And the next stage here, where the right lane is then replaced with a superstructure constructed just to the south of the existing bridge. So we're looking here at the demolition for stage one and the horizontal bridge slide for stage one. Schematics and preparing for the stage two construction. Traffic now on the stage one construction. The existing right lane is now demolished in place, and the stage two slide takes place. You'll see we had median barriers put out here to protect traffic during those traffic movements when a drop-off condition was here. Those are temporary barrier curb bolted to the bridge decks. And a detail here for the closure pour between the two halves. And an aerial view showing the work after the stage one demolition is complete, right here for the northbound bridge, and before the lateral slide of the left lane moves into place adjacent to the existing right lane span. So looking at the stage two span, this is the right lane for the northbound bridge being ready to slide from its false work, construction staging false work. And the span uh, uh, stage 2 right lane midway through its lateral slide to its final location. And the final resting here for the stage 2 lateral slide. Now both spans are being prepared now for the closure force between the segments. And a view of the completed bridge, looking northbound on Route 95. Elevation of looking from Oil Mill Road. But I'd like to just summarize our experience here with ABC. I think our early work in the 1990s proved the effectiveness of ABC. It took a little while for the department to get fully on board with that, but we certainly, by the mid-2000s, a lot of interest in additional projects that were under design at that time. But I think 2011 was really a turning point for us when we endorsed ABC as a recommended construction methodology, asking our designers to look seriously at that in all their projects for, as I said before, deck replacement, superstructure replacement, and full bridge replacement. Several years later, though, with the issuing of our ABC decision matrix, we were able to provide more objective analysis methods for assessing the viability of ABC on any given bridge project. So before that, frankly, it was a little difficult to make those decisions. Sometimes they were made because there was no other viable alternative that could be seen based on our engineering judgment. But the matrix now has provided that tool that we did not have before. As you see, we've had all different forms of ABC now in use in Connecticut, and developed a history for those prefabricated bridge elements. A number of projects here. Most high-end number are modular deck beams, including rigid frames in this category, and a number now of SPMT and lateral slide projects. For us, as I said to one of the questions in the last module, ABC is for us is now business as usual and not the exception. And we've been fortunate to have support from our administration and encouragement with this, and we've also had support, endorsement by the public sector here that lives with the consequences of what we do from a transportation standpoint. With that, the presentation is complete, and I'd be willing to accept any questions.
Thank you, Tim.
Yeah.
Connecticut has some impressive ABC projects. Thank you for letting us know about those. We'll now begin the Q&A session. Paul?
Okay, Mary Lou, thank you. And Tim, thank you. That's real good. We do have a few questions. And before we get into that, I would like to say that this is the third in-depth webinar that we've had on developing the ABC process for a state. And these are all on the archive if anyone wants to see them. They are, first of all, Utah, and then Vermont, and now Connecticut. So anyway, if you're trying to do it in your state, you need to look at that and see how they'll fit, because each one of them is a little bit different. Okay, with that in mind, first question we have here is, are there any preferred foundation alternatives that Connecticut DOT has used or plans on using for their ABC project?
I think it varies a lot. The footings are often cast in place. We have, for foundations, very often our jobs, many of our jobs are reusing foundations. We have a lot of superstructure replacements. And I'd say for many of the spans here, we still have a mix of cast in place foundations with
Yeah, I'll add to that
prefabricated bridge elements. I don't know if you want to add to that, Mike.
Yeah, I was just going to add that part of the question was future, and right now the PCI Northeast Bridge Tech Committee, which Connecticut is a member of the committee, we are now looking at revising substructure details, recommended substructure details, and what we're doing is we're taking some of the technologies that are in the ABC guide spec, the Ashto ABC guide spec, and drawing up recommended details for those. And some of those include footings and foundations, different types. And as Tim mentioned before, sometimes a precast footing is difficult because they get very heavy, and you got to level them, and the connections can be difficult to do. There's some really interesting and cool details that are in the ABC guide spec that are developed, like states like Washington State have developed some pretty neat details. So we're looking to update that in the future. So more to come as we move forward in the future. We have other ideas for foundations and footings for ABC projects.
Okay. Do you think we will see more advanced high-strength materials such as high-performance concrete used in ABC projects in the future?
Yes. Yeah, closure ports and decks and PBUs. Between PBUs or PBEs, as we call them, are the modular deck beams. Where time permits, Mike and I were discussing this earlier. Sometimes if you need a really fast set for concrete and closure pour, because of the constraints on a project, you may not be able to use ABC. So it really depends. Using UHPC really depends on the nature of the construction staging and the durations contractor has to work with.
Yeah. Another thing, Tim sits on the Ashto T4 Construction Committee, which is the home of ABC, and we've actually had discussions at meetings about, future materials. And one thing we threw out there was the concept of a UHPC that was maybe 10, 12,000 PSI concrete with steel fibers. It'd be very interesting to see what lap splices could be generated with that type of material. We can get a number 5 bar spliced in 5 inches with UHPC. But we may find that, like say, a 10,000 mix with steel fibers, maybe that 5 inches goes to 6 inches. And it's one of the issues with UHPC, to get to 20 KSI or 22 KSI, it takes a couple of days. But we could probably get to 8 or 10 KSI in hours. So, I think the future use of UHPC, it's a great material that is being studied by a whole bunch of people. And it's exciting. It's an exciting time in bridge engineering with new material. And where it goes from here, we'll leave it up to the researchers and the companies that manufacture the product to come up with new ways of using it.
Okay. How does the Ashto minimum span depth ratio work with precast ABC bridges?
I'll start with the answer. The answer is the primary form of design for ABC in the United States and in Connecticut especially is using emulation, where we emulate cast in place construction with prefabrication, either precast concrete or steel. So when we go to design an emulative bridge, the design essentially is the same as a cast in place bridge. So when it comes to span depth ratios, we apply the same approach that we would as if it was a cast in place conventional construction. You'll notice we had a couple examples showing a lot of steel structures, especially the one that Tim showed over I-95. There were 2 structures that were steel. Now, often we have a lot of older highways that have minimal clearance and were built before the modern Ashto vertical clearance requirements of 16 foot 3 inches came around. So a lot of times we have cases where we're replacing a superstructure. We can't get to 16.3, but they're built at like 14 feet 3 inches. So we try to maximize the vertical clearance, and often we end up with steel there. We do look at precast concrete. Next beams give you a very thin structure as well. However, there are span limitations of about 70 feet for those. So the key is we use the same span depth ratios for when we do type studies as we do with cast in place or conventional construction.
Yeah. Okay. How often is building information modeling for bridges, that's BIM for bridges, /4D modeling employed on ABC projects?
I don't think we have a big history of that. I don't know if Mike, if you've had any in your avenue of bridges for the department.
Yeah,
But
it's been discussed. We've talked about it. We have done some 3D modeling. We did a project in Massachusetts a few years ago where we did 3D modeling as a way of checking shop drawings to see if the actual shop drawings, we drew a 3D model of each piece and see if they actually went together. It was kind of an interesting little side thing we did. But the reality is in Connecticut, we have not used it yet. Does not mean we won't use it in the future. I think there might be an opportunity for that in the future to look at how things go together. The problem with 3D not the problem. One of the biggest issues with prefabrication is things fitting together. And I was a principal investigator for NCHRP Project 1298, looking at tolerances. A 3D model is great because everything's perfect in a 3D model. But back to earlier discussions we had in module 1, where we talked about designing for tolerances. That's an interesting aspect of it. But I see in the future 3D modeling. Yeah, I think that's where we're going, and that's where the vertical construction industry has gone. It's just a matter of time before the bridge industry switches over as well.
Yeah, I think that's probably not unique to ABC construction. So.
Exactly. I know New York State and Utah have both bid projects on the street, paperless projects done with 3D BIM modeling. So it's I think like we did with ABC, Tim, we're going to let Utah and New York figure it out. We'll run with it when it's
tag along.
time.
Right.
Okay. We're about out of time, but there is one thing here I'd like to comment. Is people are going to ask, where can we get a hold of the matrix if we wanted to play with it and experiment with it? Your ABC matrix.
It's readily available here. One of our presentations has the web address to find that here. We can certainly make that available here. If you do a Google search right now on CON.dot ABC decision matrix, you will be brought directly to the location where you can download that. So, but I can't remember. I know we have it in one of the presentations here. Do you recall which one, Mike?
I don't, but you're right, Tim. Just Google search CTDOT ABC decision matrix. It'll pop right up in Google. First site.
Yeah, it'll be right in your lap. I've done it a number of times myself. Sometimes it's quicker for me to do it that way than go through the steps I need to use if I'm going through our DOT library here.
Yeah, same thing here, Tim. And the key thing is you download the matrix. Plus, also there's about a file that tells you how to use the matrix is included.
Yeah, there's a guide. It's about a 6-page guide that tells how to use it. And anyone that really wants to dig deeper on it, we can provide a password for that, so you can play with the weights or the variables here, the weights in the rating table. But we certainly are going to be going back and revisiting the weights in the rating table at some point here, which is probably overdue at this point in time. But I think the starting point is play with the matrix as it is right now and see what you think. Use the guides, and I'm certainly available, or Mike would be as well, to answer any questions on that.
Yeah, I know we're over time, but one thing I'd just like to add, Paul, at the end is that, this is the Connecticut DOT way of doing decision making. It doesn't work for every state. Every state has different needs and goals. But that's why Tim said if you're a state DOT and you want to do a decision matrix similar to Connecticut, Tim will get you the password to get in there and start making changes. But we're not trying to say this is the only way to do ABC decision making. It's what works well for Connecticut, and something similar might work.
We've weighted the ABC measures to CON.dot priorities, but you got to keep in mind, viewers need to keep in mind, we're a densely populated state. We have high traffic volumes, and we have a population. Our residents are not hesitant to let us know when we're unduly restricting traffic flow. So we put a high premium on maintaining traffic here. But every state is different. You may have less traffic density and not want to rank, say, user costs as highly as we do, say.
Okay, Mary Lou, it's past a quarter after. Go ahead and take over.
Yeah, I think we need to conclude. Thank you, Paul. We're now at the end of the 6th and last 40-minute module. Thanks again to Tim for presenting the 6th module, and to Tim and Mike for answering participant questions. This completes the 2021 in-depth web training on the development and implementation of Connecticut DOT's ABC program. All of us at the ABC UTC would like to again thank you, Tim and Mike, for sharing your expertise and experience for all our participants today. Thanks also to Paul Lyles and Ahmed Abu Hawash and Jugesh Kapoor for moderating the Q&A session, to Ali Javid for working the web room, and to all of you who attended this web training today and participated in the Q&A sessions. This web training is now ended. Thank you so much.